This time we are looking at geometric sequence in which the third term is 8 and the common ratio is 2. Again, in the first part, what we're asked to do is find a bunch of individual terms. And first I ask for the fourth term, then the second term, and then the first term. Well, since I know the third term and that the common ratio is 2, to get from the third to the fourth, we're just going to multiply by the common ratio. 8 times 2, that's going to be 16. But now if we're going to move backwards to the second term, instead of multiplying by 2, we're going to have to divide by 2. So 8 divided by 2 is 4. And to get back one more step, we divide again. So 4 divided by 2 is 2. And now we can see the first few terms within the sequence being 2, 4, 8, and 16. In part B, I ask you to verify that A1 is equal to 2. And we're going to do that by looking at that third term. And how do we make the third term? Well, we make it by taking the first term times the common ratio to the n minus 1th power. The common ratio in this case is 2, and since 3 is n, the power is going to be 2 as well. And we know what the third term is, that's 8. So a little bit of algebra, this says a1 times 2 squared is 4, and if we divide by 4, a1 is 2. Part C says to come up with a sub n. Well, again, we remember that formula as being the first term times the common ratio to the n minus 1th power. Our first term here we already found as being 2, so I'm going to plug that right there. And our common ratio is given to us, it is also 2, so I'll put that one in right there. This is a good enough expression. If you want to simplify it, we know that 2 is 2 to the first, so we have two exponents with the same base. So if I'm going to multiply those two together, we just add their powers, and 1 plus n minus 1 is going to be n. So another expression for the nth term is just 2 to the n. And that's great to know because in part D, we're asked to find the sum from k equals 3 up to 14 of 2 to the k. So that means we are still talking about this series. Anyway, we have to start by plugging in the k equals 3 for k. So 2 to the third power is 8. Then we'll plug in 4. 2 to the fourth power is 16. And we're multiplying by 2 every time. So next one's going to be 32. And we go up to our biggest one. In this case, our biggest power is going to be 14. And 2 to the 14th is 16,384. Anyway, we know that it's geometric. We know it's not infinite, so we can use our finite geometric sum, which is going to be first term minus first term. Inside the parentheses is going to go the common ratio, in this case is 2. And our power. Well, we need to know how many terms there are, and that's where we go back to this notation right here. How many terms are there if we start with the third term and go to the 14th term? This is where we need to subtract the 2. 14 minus 3 is 11. And then add 1. So the power is going to be the 12th power. Anyway, now it's time for the calculator to calculate. And when it's all said and done, your calculator should give you 32,760. If your calculator isn't giving that to you, you have to pay attention to how you're entering it in. Maybe it might come down to entering an extra set of parentheses around the numerator and the denominator or something like that. But make sure you know how to enter it in your calculator correctly.